All right, so there's a lot of stuff written already. Because to save some time, obviously, so in the video. And in cases like this, as I mentioned before, take some time to write it down. So pause the video right now, take some time to write it down. This is the way to choose the pivot in the simplex algorithm. And then I'm going to comment and read it with you essentially to pinpoint the essential steps. All right, so assuming you already wrote it down, let's focus again on the topic of the class today, right? So we want to describe the algorithm, and we already know how to set up the simplex tableau. We already know how to perform the pivot operation. The only thing that's left is to see how we choose the pivot. So that is the core of the lesson today, choosing the pivot, deciding the outcome, whether we reach the solution, the maximum solution, or there is no solution. And then if we can choose a pivot, so if there is still pivoting required, we perform the pivot operation, and then we analyze again the first part. So basically the algorithm is essentially choosing this pivot, so that will be basically step 1 over here, and then step 2, pivot operation. That will give you another simplex tableau, and then you redo step 1 until you stop. So when you choose the pivot, there are 2 conditions in which the algorithm stops. And I'll comment on that in a minute. When you choose the pivot, basically you choose first the column of the pivot. And that column corresponds to the first from left to right. I should write here. So the first from left to right. So you choose the first negative entry in the objective row, in the P row. That is the pivot column. If no negative entries on that row, then you stop. It means you reach the solution. So basically the current values give the solution if there is no more pivoting required. Then you pick the row corresponding to the of the pivot, and that row will be corresponding to the least positive ratio between the entries on the right hand side and the column you chose above. You're going to ignore the negative entries, so you ignore the negative ratios, in other words, and choose among the left ones, the remaining ones, choose the one that gives you the least of that ratio. If there is no positive ratio, that means you are in the case in which the problem has no solution. So let's illustrate with an example, obviously, how we do this. Often you do only one pivoting operation and the algorithm stops. I'm going to choose one in which you need to do, let's see, at least, I think 3 pivoting operations. So hopefully we have enough room here. And then we're going to do a word problem later on. So just for simplicity, we're going to start already with the initial simplex tableau. Not for simplicity, but just to speed up the process a little bit. So the initial simplex tableau, boundary value, basic variables, p, x1, x2, x3, x4, s1, s2, and the right hand side. And in fact, we might actually even write down the actual problem. So this corresponds to 2x1 plus 4x2 plus 5x3, 6x4 less than or equal to 24, 4x1 plus 4x2 plus 2x3, 2x4 less than or equal to 4, and we want to maximize p equals x1 plus 2x2 plus x minus x3 plus 3x4. Okay, so if you do the table correctly, the initial simplex tableau, this should be 0, 0, 1, 2, 4 minus 1, 4, 4 minus 2. 5, 2, 1. 6, 2 minus 3. Let's see, 1, 0, 0, obviously, 0, 1, 0, and the right hand side will be 24, 4, 0. And then the basic variables will be S1, S2, and P. You know, you could actually skip that column until you actually reach the final Tableau, right? Because that column actually is important when you end up writing what the maximum is when you reach the stopping criteria of the algorithm. Okay, so let's pay attention how we choose the pivot. From left to right, you're going to choose the first negative entry. So that's going to be the column of the pivot, column 2. Then we're going to ignore the negative entry minus 1, and then we're going to look at the ratios. You can even have another column here for the ratio if that doesn't make sense, right? If it's not clear already. You're going to do the ratio between the right hand side and each entry in that column. So 4 divided by 4, 24 divided by 2. Right, so the ratio between right hand side and the pivot column. And that gives me 1 and 12. So the least positive ratio is going to be corresponding to that entry 4. Okay, so that's going to be the pivot. Let's do the pivoting operation. So we're going to do it in 2 steps as before. And again, we're going to do the labels later. So copy the first row for now. And make sure you don't lose anything because there's lots of entries. Divide by 4. So that's going to be row 2 divided by 4 to make it 1. 0, 1, 1, 1 over 2, 2 over 4, right? 1 over 2, 0 over 4, 1 over 4, 4 over 4, which is 1. And again, circle the pivot so that you don't lose it. And then move on with the algorithm. We're not done with the pivoting operation yet. We need to update the row 1 and 3, right? Because we need to make zeros above and below the pivot. So we're going to do minus 2 row 2 plus row 1. And then row 2 plus row 3. And of course, we're going to change row 1 and row 3. So we have 0, 0, let's see, minus 2 times 1 plus 4, that's 2. Minus 2 times 1 half, that's going to be minus 1 plus 5, 4. Minus 2 times 1 half, again, is minus 1 plus 5 is 5, plus 6 is 5. Minus 2 times 0 plus 1. Minus 2 times 1 over 4, that's minus 1 half, plus 0. Minus 2 plus 24, that's 22. Let's double check. Minus 1 half, 22. Obviously, copy the pivot row. And now add the pivot row to the last row. Row 2 plus row 3. 1 plus 1 half. Minus 3 plus 1 half. Let's do a little scratch paper. That's going to be minus 6 plus 1. That's minus 5 over 2. 0. 1 over 4. 0 plus 1. Okay, we're done one pivot operation. Okay, do we still have negative values in the last row? Yes, we pick the first negative value. That's going to be the pivot column. And again, remember, the right hand side column is the last column. Perform again the ratios. 1 over 1, ignoring the negatives, of course. 22 over 2, that's 11. Okay, so that means the entry corresponding to the least positive ratio is going to be that one. Fortunately, the next pivoting operation is going to be faster because it's already 1. So all I have to do at this stage is to do, let's see, minus 2 row 1, minus 2 row 2 plus row 1, just like before. And then row 2 plus row 3. So the new tableau is going to be 0, 0 plus 1, 2 plus 1, 4 plus 1 half, that's going to be 9 over 2. 5 plus 1 half is 11 over 2. 1 plus 0, minus 1 half, it's like minus 3 over 4, so it's minus, so minus, sorry, I forgot to multiply by, 1 second, I forgot to multiply by 2 actually here. I got carried away. So minus 2 times 1 plus 2 is 0. I think I skipped, yeah, I forgot to multiply by minus 2. I got carried away. So 0 plus 0, 0 minus 2. And then it's 3, because it's going to be minus 2. No, it's going to be 0 next one, obviously, because it's going to be the third entry, minus 2 times 1 plus 2, which is going to be 0 over here. It's going to be a mess here, actually. So minus 2 times 1 half minus 1 plus 4 is 3. So let's make this 3. Hopefully it's easy enough to see. Minus 2 times 1 half is minus 1 plus 5. That's a 4. Minus 2 times 0 plus 1 is 1. Now minus 2 times 1 over 4, it's minus 1 half with another minus 1 half makes it minus 1. And then minus 2 times 1 plus 22, that's going to be 20. So the first row is 0, minus 2, 0, 3, 4, 1, minus 1, and 20. And then copy the pivot row. And finally add the second row to the row number 3. 0 plus 1, 1 0 plus 0, 1 minus 1 is 0. 3 over 2 plus 1 over 2, that's 4 over 2, which is 2. Minus 4 over 2 plus 1 over 2, that's minus 2. 0 plus 0. Let's see, 1 4 plus 1 4 is 1 half. And then finally 1 plus 1 is 2. 1 1 0, 2 minus 2, 0 1 half, and 2. So I actually purposely chose this example to have more pivoting operations just to see how it evolves. Many problems, just to make them short, will stop when you have after 1 or 2 pivoting operations. So notice we're still not done, right? You still have negative entries in the P row. So you still have to do the pivoting operation one more time. So this is the pivot column. When you do the ratios, be very careful because 1 divided by 1 over 2, that's actually 2. So make sure you're careful when you do the ratios here. 20 over 4, that's 5. So the pivot is going to be this guy, 1 over 2. To make it 1, obviously we multiply the row 2 by 2. So the intermediate tableau is going to be 0, minus 2, 0, 3, 4, 1, minus 1, and 20. And the pivot row is 0, 2, because you multiply that row by 2, remember? 0, 2, 2, 1. Oops, not this one. Oops. I wish I could actually raise it. So 1, and the second one is the pivot, this guy. This thing doesn't work with the erasing part. So 1, 2 times 0 is 0, 2 times 1 over 4 is 1 over 2 and 2. 1, 1, 0, 2, minus 2, 0, 1 over 2 and 2. Okay, and finally, again, looking at the second circle here, we do minus 4 row 1 plus row 2 plus row 1. And then we're going to do 2 row 2 plus row 3 to make zeros above and below. All right, so 0 the first entry. Maybe let's actually leave this time room for basic variables because it's going to be the stopping point. So basic variables p, x1, x2, x3, x4, s1, s2, and the right hand side. So 0 plus 0, 4 times 2 minus 2, or 8 minus 2, that's 6. No, minus 4 minus 2 is minus 10, I'm sorry. Minus 10 over here, because it's minus 4 times 1 plus 4. So here is minus 4 times 2, minus 2 is minus 10. Minus 10. Then it's minus 8. Then minus 4 times 1 plus 3 makes it minus 1. Minus 4 times 1 plus 4, that's 0. Then this is still 1. Minus 4 times 1 half, that's minus 2, and with another minus 1, that's minus 3. And then the right hand side, minus 8 plus 20, that's 12. Copy the pivot row, 0, 2, 2, 1, 1, 0, 1 half, and 2. And then finally multiply row 2 by 2 and add. This stays the same. This becomes 5. This is 4. 4, 0. This is still 0. 2 times 1 half is 1 plus 1 over 2. That's 3 over 2. And finally 2 times 2 plus 2. That's going to be 6. All right, so no negative, that means the algorithm stops. And now you read the basic variables. The first basic variable is S1. The second basic variable is X4. And the last one is P. So X4 will be 2. And the other ones, because are not basic variables, are 0. And P is 6. So the maximum is P equals 6, which is attained for X equals 2, X1, X2, X3 equals 0, and X4 equals 2. All right, so we're going to do another problem, this time a word problem on the second page, so stay tuned. All right, so let's take a look at this problem and let's read it carefully before we extract the data that we need to. So a large hospital classifies its surgical operations into 3 categories according to the length and they charge a fee of $1,200, and $2,400 respectively for each of these categories. We have the average time of each of these type of operations. So for each of them is going to be 30 minutes, one type, 1 hour, another type, and 2 hours, another type. This is one of those problems in which you have to be careful not to use the numbers incorrectly. So for example, because the number of variables we know already is going to be 3, right? The question is how many operations of each type we should have in the hospital to maximize the revenue. So 4 operating rooms only matters in the sense that you multiply that 4 by 10, right? Because it says the hospital has 4 operating rooms, each of which can be used for 10 hours per day. So basically they have 40 hours available in a given day. So that means if we take the number of operations of each type and we multiply by the time for each operation, the average time, then altogether this should not exceed 40 hours available. So the fact that they have 4 operating rooms or less or more doesn't matter. You basically have the whole capacity available, and you measure that in number of hours available, which is 40 in this case. And of course, we have the total number of operations that cannot exceed 60. So obviously the money part, 12,000, 1,200, 1,800, and 2,400, that comes into the objective equation. So if you want to pause a little bit and think about how you extract the information, and then you continue with the video to see the way we set up the problem. All right, so let's try to write down the data for this problem, right? So we have 2 types of operations. So type 1, type 2, type 3, and the variables will be the number of type 1, the number of type 2, the number of type 3, denoted by, so number of type 1 denoted by x1, denoted by x2, the number of operations of type 2, and by x3, the number of operations of type 3. So remember, as in all of these problems, you have basically the information given for each operation. So each will give you a revenue of $1,200, the first type, 1,800, 2,400. So that is the revenue. And then you write again the information on the row like that for the other ones. Each of them takes some time, right? By the way, the time is given in minutes, 30 minutes, and then hours. So let's work in hours, right? So the first type takes half an hour. The second type, each of them takes an hour. And then the third type takes 2 hours. And remember, all in all, we have 40 hours available, because we have 4 operating rooms with 10 hours each available. And then the total number of operations cannot exceed, so the total number of operations cannot exceed 60. So you can find your own way to derive the information and write it down in a nice way, but you got to extract the information in some sort of schematic manner like this. And now let's try to write the constraints. So the fact that you can only do 60 operations at most, that means the sum of x1 plus x2 plus x3 should be less than 60. Then how many hours do you need for all of these operations? Well, half an hour for one of this type, x1. So that means 1/2 times x1 is the number of hours of the first type. 1 times x2 is the number of hours of the second type. 2 times x3 is the number of hours of the third type. Altogether should be less than 40. The goal is to maximize the revenue. So it's to maximize P equals, now multiply the revenue per type, multiplied by the number of types. So 1,200 x1 plus 1,800 x2 plus 2,400 x3. And so notice this becomes a maximum problem in standard form. Obviously the positivity or the fact that these are non-negative is automatically understood because, well, the number of operations can only be a non-negative number. So introduce slack variables. So now we proceed with the simplex algorithm. Move everything on the left side on the objective function, objective equation, I mean. And now proceed with the Simplex Tableau. I go a little bit faster because by now you should be familiar with all of these, but I strongly advise to pause, do the steps ahead of time, and then continue the video and check to see if you did it correctly. So we have the boundary, the basic variables p, x1, x2, x3, s1, s2, and the right hand side. So let's see how this initial simplex tableau looks like. So we have 0, 0, 1, 1, 1 over 2, minus 1200, 1, 1, minus 1800, 1, 2, minus 2400, 1, 0, 0, 0, 1, 0, 60, 40, and 0. Once again, we may not need actually the basic variables until the end, but just to remind people that these are the variables corresponding to the columns of the identity matrix. 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, so let's see how we decide the pivot column. That's the first, that's the one corresponding to the first negative entry. And now we choose the row of the pivot by performing the ratios, the positive ratios. 40 divided by 1/2, it's 80. 60 divided by 1 is going to be 60. So the least positive ratio corresponds to that entry, 1. Fortunately, it's already 1, so we don't need to divide the pivot row by anything. We just use that pivot to make zeros below. So we're going to do 1/2 minus 1/2 row 1 plus row 2, change it to row 2, and then 1200 row 1 plus row 3, and we're going to change row 3. We may have to use the calculator for this one. So let's copy the, especially when you have the same number of entries here, make sure that you don't miss any of them. There's 4 ones in the first row for now. And now let's change. Minus 1/2 times 1 plus 1/2, it's 0, obviously. Minus 1/2 times 1 plus 1, that's positive 1/2. Minus 1/2 plus 2, that's going to be 2 minus 1/2, which is 3 over 2. 0 minus 1/2. 1 minus 0 times 1/2, which is still 1. 40 minus 1/2 times 60, that's going to be 40 minus 30, which is 10. So that's going to be 10 over here. And then the pivot, the P row, 1200 times 1 plus 12 times 1 minus 1200. Let's see, 1200 minus 1800, that's minus 60. Then 1200 minus 2400, that's minus 1200. Yeah, that's minus 1200. That's correct. Then minus, no, 12, what do I do? Yeah, 1200 plus 0, that's going to be 1200. And I'm at this one, 0 times 1200 is still 0, so that's still 0 plus 1. Looking at thing at the wrong oh, I'm looking at the wrong entry. Sorry, this is 0 because it's 0 plus 0. So yeah, and then 60 times 1200 plus 0, which is 72,000. One 0 minus 600 minus 1200, 0, 72,000. Okay, we still need to pivot, right? Because we still have negative entries on the P row. Now the pivot column is this one, the third column. And let's look at the ratios in order to pick the least ratio. 10 divided by 1/2, that's 20. 60 divided by 1, that's 60. Which means the least ratio is going to be 20. So that's going to be my new pivot. All right, so let's do the pivot row to make it, the pivot to make it 1. So we're going to do 2 times row 2 first. to change it into 1. So now the matrix is going to be 0, 1, 1, 1, 1, 0, 60. Now multiply by 2 so that the pivot becomes 1. 3 minus 1/2, 2, 20. Copy the rest for now. And now we're going to perform the zeros above and below the pivot. So we're going to do row 1 minus row 2, change that into row 1, 600 row 2 plus row 3, and change that into row 3. All right, so 0 minus 0. So let's actually leave now room for the, I'm anticipating a little bit because that'll be the stopping point you'll see. Basic variables P, x1, x2, x3, s1, s2, right hand side. So P becomes 0 plus 0, 1 minus 0, 1 minus 1, 1 minus 3, 1 minus negative 1, 0 minus 2, 60 minus 20. All right, copy the pivot row, obviously 0, 0, 1, 3, minus 1, 2, and 20. And now 600 times row 1 plus row 3, 1, 600 times 1, 600 times 1 minus 600 is 0, 600 3 minus 1, one second, 600, so multiply by 2, I'm trying to look to see if actually the pivot row 600, yeah, okay, I was looking at the wrong entry again. So 3 times 600, that's 1800, minus 1200, that's 600, 600, um, 600 row 2, missed the 0 actually here, this is still 0, skipped one entry, so 0 times 600 plus 1, 0 plus 0, and now it's 0 again, and now finally 1800 minus 1200, that's 600, and then minus 600 plus 1200, that's another 600, and then 2 times 600, that's 1200 plus 0, and then finally that's a huge number now, 20 times 600 plus 72,000, that's gonna be 84,000. All right, so I think that's all good. All right, so no negatives on the last row means that the algorithm stops. Now we look at the basic variables. The first one is x1. The second variable, basic variable, is x2. And then of course p is always the basic variable. So remember, the basic variables have the right hand side assigned to them. If it's not a basic variable, automatically it's 0. And p in this case is 84,000. So that's going to be the maximum. As a double check, you can plug in p, the value, the current value of p, and the current values of x1, x2, x3, all the way back into the objective function over here to see that they satisfy the equality. So 1200 times x1, which is 40, 1800 times x2, which is 20, and then 2400 times x3, which is 0. This is basically like a double check, because if you perform the computation correctly, you don't need to do that. I mean, for sure, the maximum is given in the last Tableau as a basic variable. So in this case, P, let me write it here again. So P equals 84,000 is the maximum possible revenue. And it is attained if you use these operating, I mean, if you use that many types of operations, right? 40 of the first type, 2 of the second type, and none of the third type. Actually, that's an interesting kind of problem if you think about, because it suggests that, you know, you can get the maximum revenue if you don't use at all one type of operation. So hopefully in practice, the way you schedule the operations is not just dictated by these conditions, because, you know, some operations could be mandatory. So that's it. Depending on the situation at hand, we may add some examples later. But for now, you should have everything you need to attack section 5.2, the homework. And that's it for today.